Hi, welcome to my video on more problems using the sine law. And the first problem is, before I begin, to remind you that you can pause the video and work each of these answers out first as you do the questions. So the first question is, find the area to the nearest square centimeter. The units are centimeters. I have two sides at an angle, and it's not a right triangle, so I can't use SOHCAHTOA. And I have an angle and a side opposite the angle, so I can use my sine law. So the sine of 82 over 10 is the sine, and I know I can use the sine law, but let's look. If I have an angle and an opposite side, then I can use this side. I can pick up angle B, and after I get angle B, then I can subtract from 180 to two of these to get this angle. And because I need the area of a triangle, I need the area of two sides and an included angle. So let's get angle B first, and then we'll get angle C and use these two sides and the angle here to do the area. So the sine of angle B is equal to the sine of 82 over 10 is equal to the sine of B over 5. And the unknown, do it quick. Sine of B is the unknown, so it's 5 times sine of 82 divided by 10. So that works out to be, the sine of B is 0.4951 to the nearest 10 thousandths, and that means that angle B, and you can use your calculator, should know how to do that by now, 4951, and angle B comes out to be 30 degrees. So angle B is 30 degrees. We practiced this before working out this on the calculator. So angle B, so that means that angle C is 180 minus 82 minus 30, and when you work that out, you get a 68. So angle C is 68. So that means the area of a triangle is a half of AB sine of theta, or the included angle. So that's a half of 5, or you could say 10 if you want to call it A. B is 5, and it's the sine of 68 degrees. And use your calculator. A half times 10 times 5 times sine 68 gives you 23.179. So that means that the area to the nearest square centimeter is 23 centimeters squared. Okay, here we go. Another one. Find the exact value of x. So we have a triangle. Again, it's not a right triangle, so we can't use SOHCAHTOA. We have an angle and an opposite side, so we can use the sine law. So the sine of 120 over 18 is the sine of 45 over x. So now that we have this sine law written out in relation to these numbers, cross multiply, we have x sine 120 equals 18 sine 45. And the reason I never wrote it like this, because I want to find the exact values of sine 120 and the sine of 45. And 120 degrees on a circle is right here, roughly. Terminal arm perpendicular to the x-axis, so that's 120 degrees. This arc from here to here is 60. That means this central angle is 60. This is the 30. Hypotenuse is 1. Opposite 30 is a half, but is negative in this quadrant. Opposite 60 is root 3 over 2, positive, because the y is going up. So the sine of 120 is the same as the sine of this 60 right now, which is root 3 over 2, because the sine is the y. Or it could be opposite over hypotenuse, and since the hypotenuse is 1, root 3 over 2 divided by 1 is root 3 over 2. And the sine of 45, draw a circle, and 45-degree angle is the first quadrant right here. And a right triangle, so this angle in here is 45 on the rotation. This angle here is 45. Hypotenuse is 1, so both of these sides are root 2 over 2 in a 45-45 right triangle. So the sine of 45 degrees, sine is root 2 over 2. And cos is root 2 over 2 because they're the same. So let's take our time, work this out. So that's root 3x over 2. 2 cancels into 18, 9. So there's 9 root 2. And I put it over 1 and cross multiply. So I get root 3x. 2 times 9 is 18 root 2. And I divide both sides by root 3. They cancel, I get x. And you got a radical on the bottom, so you multiply by the conjugate roots. The conjugate of root 3 is root 3, because when you multiply root 3 by root 3, you will pick up a 9. Sorry, root 3 times root 3 is root 9, which is, better be careful, which is just 3. And we get 18 root 6. And 3 into 18 goes 6. So x is equal to 6 root 6 as an exact value. Okay, let's work out some more problems. The more problems we do, the better we'll see what's happening. We have something like an ice cream cone here, and we have AHC as a hemisphere. That means it's a half a sphere. And find the area of the shaded region. And we're given the length of this side is 8, and these angles are 70 and 50. So I want to get the length, the area of the hemisphere. Shaded region is a hemisphere. So I need to get the radius of this hemisphere. In order to get that, I need to get the length of AC and take a half of it to get the radius, and then I'm able to work out the area. So I have a 70 and a 50. So this angle B is 180 minus the 70 minus the 50, and that works out to be 60 degrees. So this angle B is 60 degrees. Now, notice I want to get the length of AC, so I need to use a 60-degree angle with this AC, and this is a sine law because I have an angle on the side. So the sine of 50 degrees over 8 is the sine of 60 over AC. And we got one unknown, so AC is equal to 8 times sine 60 divided by the sine of 50. Use your calculator and work that out, and AC comes out to be 9. Now, AC is the diameter, so that means the radius is half of AC. So it's a half of 9, so it's either 4.5, or you could say 4 1/2 as a decimal or a fraction. Now we need to get the area of a hemisphere. So the hemisphere is half a circle. So it's a half of, the area of a circle is pi r squared. So it's a half pi, and we want to get it to the nearest tenth, so we can use decimal or fraction. Don't make any difference, your choice. 4.5 squared. So if you plug all of that into a calculator, then that works out to be, let me use the calculator now to make sure that it works out, just to show you, 0.5, and I'm going to put pi in the calculator. I could put 3.14, bracket is 4.5, and I'm going to square it. So notice it's written down the same as what I have right here. Half is 0.5 pi, and I hit the enter button, and I get 31.8, which is the area to the nearest tenth. So that's feet, so this is square feet. So that's the area as a decimal. But what about we want the area in terms of pi? So the area is a half pi r squared. So we want it in terms of pi, so we leave pi here. We won't, again, like we did here, but the radius is 4.5, or we could say 4.5 or 4.5 as a fraction. So that's 4.5 is 4 times 2 is 8. That's 9 over 2 squared. So that's a half pi. And 9 squared is 81. 2 squared is 4. So we multiply that, we get 81 pi over 8 as in terms of pi. Or we could go a decimal, 10.1. You could go 10.125 pi, but we need pi. We don't put pi in the calculator, we just leave it alone. So that's, just wanted to emphasize that. Okay, number 4. And if you take, let's just check. Let's do a little check here. Let's take 10.125. Let's clear it. 10.125, and we put a pi in. And we come up, so this is a decimal approximation. This is in terms of pi. So these answers are the same. The only difference is here, pi is 3.14 converted to a decimal, and you get this. Number 4, again, don't forget you can pause your videos at any time and work these out yourself. 2 forest fires, P and Q, are 8 kilometers apart. A ranger from station P spots the fire 15 kilometers away. The angle at Q is 53. How far is the fire from station Q to the nearest kilometer? Well, let's draw a diagram. The diagram helps us, or helps me anyway. P and Q are the 2 fire stations. They're 8 kilometers apart. And they spot the fire. So let's call the fire down here F. And ranger at station P spots the fire. And this fire is 15 kilometers away. And the angle at Q is 53. So the angle at Q, P, QF, the angle that the ranger at station Q has between the station P and the fire, this angle is 53 degrees. And we want to find how far the fire is from Q. So there's the fire, there's Q, so there's X. So we have not a right triangle, and we have an angle on the opposite side, so we'll do the sine law, the sine of 53 over 15. And we want to get what X is, but we don't have this angle, we don't have this side, so we can't use this. So what we'll do, we'll find what angle F, we find what this angle at F is first by using this 8. So the sine of 53 over 15 is the sine of F over 8. So I can't get this distance here because I don't have this angle. So that means I got to get this angle F first, then get this angle, and then we'll be able to get what X is. So here we go. So the unknown is the sine of F is equal to 8 sine 53 divided by 15. So the sine of F is equal to 0.4259. So if you take your calculator and work this out, you get the decimal. So angle F is sine to the -1, that's inverse of 0.4259. So angle F comes out to be 25 degrees. And what we have to check is for what is the other angle? Well, let's just check to make sure, because there could be two possible angles, but we'll just check. So 25 degrees is in the first quadrant, right here. So in the second quadrant, where sine is positive, the reference angle is also 25. So this reference angle here is 25. So this rotation right here must be 155. In other words, it's 180 minus the 25, which gives me 155. So now we got two angles, and we check. So this angle is 155. So if we put F to be 155 and this to be 53, then this angle is too much, because that'll be 208 degrees. So we can't use that angle. So F is the only angle that's working. So F is 25. So that means that angle P is 180 minus 53 minus 25, that's degrees, and that angle comes out to be 102. Now we have an angle on an opposite side. Here we got an angle but no side, so I'm going to do the sine law on that. So the sine of 53 over 15. Notice we know this angle on this side, so on this sine law I use this one because that's the known, and also here again I'll use this same one because we know that's the given information. So this is the sine of 102 over x. Again, x is equal to, cross multiply, 15 sine 102 divided by the sine of 53. And x comes out to be, to the nearest kilometer, 18 kilometers. And we have this worked out. Okay, let's continue. Another one, don't forget to pause the video. In a triangle, two angles measures 30 and 57. The side opposite the largest angle is 4.2. Find the length of the smallest side. Well, let's draw a triangle, and I'm not particular on what the angles are. I'm just drawing a triangle, and even though the triangle could be obtuse sometimes, I just make it acute. So the angles of the triangle are 31 degrees and 57 degrees. The side opposite the largest angle. Well, let's see what the other angle is. 180 minus 31 minus 57. So that angle ends up to be 92. So there's the 92. So 31, 57, and 92 adds up to 180 degrees. So the side opposite the largest angle. So if this is the largest angle, then this opposite that largest angle, which is the longest side, is 4.2. Find the length of the smallest side to the nearest tenth. So the smallest side, this is the smallest angle, so let's call this smallest side x. Again, opposite the largest angle is the longest side. Opposite the smallest angle is the shortest side. So now we're going to use the sine law. So the sine of 92 over 4.2 is the sine of 31 degrees over x. And again, x is the unknown, so let's put x right here. And we cross multiply, so it's 4.2 times sine 31. And we divide it by the sine of 92. Plug that in your calculator, and it works out to be 2.2. And the length is in centimeters, so that shortest side is 4.2 centimeters. Okay, and we have number 6, another one to do. We have a triangle. Notice this is a right triangle. Hypotenuse is 20. The angle is 37. Right angle. Find x in two different ways to the nearest unit. So, because it's a right triangle, I can use SOHCAHTOA. SOHCAHTOA is Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So SOHCAHTOA, because I have a right angle. So on this right angle, I know the angle is 37. So this is the hypotenuse, and this is the opposite side. So I need to find x, so I need to use sine is opposite over hypotenuse. So the sine of the angle 37 is x over 20. And put it over 1, cross multiply. 1 times x is equal to 20 sine 37. And x comes out to be, to the nearest unit, 12. Okay, how's another way we can do it? Well, notice we have an angle of 90 degrees and a side, so we can use the sine law. So the sine of the angle, 90, sine of 90 over 20 is the sine of 37 over x. And the sine of 90 is a 1. Cross multiply, 1 times x is x, and we get 20 sine 37. And 20 sine 37 is the same here and here, so that has to be the same answer, 12. And just to remind, I can use my calculator and go sine of 90 if I want. The sine, turn the calculator around, sine of 90 degrees is 1. Or, if you think about it, we have a unit circle. This point is 1, 0, so the radius is 1. So this point here is 1, 0, this point here is 0, 1, and this is 0 degrees, and this is 90 degrees right here. So at 90, sine is the y, so the sine of 90 is 1. The cos of 90 is 0. So the sine of 90 is 1 on this circle, or I can use my calculator and I can work out the 12. Two different ways, your choice. Most people would say this is a right triangle and they would use SOHCAHTOA. I just want to illustrate that because we have an angle on an opposite side, we can use the sine law. Always be thinking. That's what math is about. We have a right triangle ACB, and it says use the sine law and show that the sine of A is A over C, which is the adjacent side over the hypotenuse in a right triangle. So this is angle A, so this is small a. This is angle B, so this is small b. This is angle C, so this is small c. So notice we want to say the sine of A. So if we use the sine law, the sine of A, I need the sine of A is over small a. And also I have an A, sine A, angle A, small a, and I have a C. So that means if I got a small c, I must be having the sine of angle C over C. So this is angle A. This is small a, small c, so the angle C is what I need. So that's the sine law based on an angle and a side in each, an angle and a side, the sine of A over A, the sine of C over small c. So, but angles A is, we don't know, over small a, but notice angle C is not missing. So the angle, the angle C is missing. So that means the angle at C is the 90 degrees. So that means sine of A over small a. And just then we worked out the sine of 90, which is 1. So cross multiply, we get C sine A equals, A times 1 is small a. So we divide by small c. So the sine of A is A over C. So what we did here, when I'm just illustrating that we know because of this is a right triangle, we can use SOHCAHTOA and get A over C. But we can also use the sine law to work this out. Just wanted to do a question that's a little tiny bit different. Again, angle C is 90 degrees, so the sine law works out perfect, similar to doing SOHCAHTOA, because the sine of 90 is a 1, and then you can work out your ratios. So there's more problems using the sine law. And if you like my video, click on the like button, click on the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.